the flux. So it runs, you have a real tight gap, and you have no loss of flux to free space. So it's all confined in that coil. And that's very important to do. Now what I'm doing is I take it and I'm C-clamping it around the magnet rather than side to side like that, because I don't like this. I wanted to have my north-south, north-south, rather than north-south on one side. I wanted to have it clamped around so they're all in the same direction. And that makes a big difference on these Bedini type motors. Now, your U-cores, this was an analysis they did with a gearbox, with direct drive, and then with 3 stacked rotors. And they find that just direct drive produced the most wattage output for their number of cores they put on there. They were using 564 cores. It's a pretty big generator they've got. That's what it takes to get the 600 kilowatts out of it. So this thing's a massive unit. And now here's some other type designs they have, small type, and this one here has a lot more power to it, obviously, but it's, you can use little ones like that too and do some interesting things. They were also comparing a small magnet layout versus a big one, and you get better performance out of the big one. So, let's see what else we've got in here. Here's a little bit of some machine layouts they have. Now here's the picture I wanted to show you of the unit. That's, I believe it's about 3 feet wide, and let me focus that a little better for you. That's their assembled unit. That's their 600 kilowatt unit, I believe. Yeah, 600 kilowatts. And just one of their mock-up units. About 3 feet wide and almost a megawatt. So imagine driving that with a self-running motor. And you can have the self-running motor here, 600 kilowatts. You just need to develop the torque on these type EV gray motors a little bit better. And right there you have the basis of a power plant that's much better than nuclear. So self-running electric motors running axis type generators. And that will give you a lot of power in a very condensed space. And that's sort of my old type design. So. Okay, now what I wanted to show you here is some magnetic modeling that I was doing for that ceiling fan motor, which is right over there. Now this was just a mock-up design, and it's something that you can build. I can't show you my much better units and much better improved things. I have a whole bunch more design improvements and things, but I'll show you some basics. And this is a point that I wanted to convey to a lot of you, is that now this is your ceiling fan body in CAD. I'll bring it in a little closer. And what you can see here is these are your magnets. And this is 2360 Gauss off that magnet. Down in here you're in 2800. Up here 2540. The real light areas are where the magnetic flux is real intense. The field is very intense going through this core. Now this was originally a rectangular core, but I wanted to machine it just into the areas where the magnetic flux is peak. You don't need any of this. You're actually losing, and the more metal you have, the more you're wasting all that energy into the material. So look at it as if it's wasted water flow, just like electricity. Magnetic flux moves, but it's a different form of energy. It's just another component of the quanta. So here, see how it's faded here? You really only need the hot spots. You don't want all this faded area. So, but when you make your coil to match, your core, the question is, what size should the core be? Should it be small? Should it be big? Most people will design kind of like this, where they have a core that's about the diameter of the magnet. So, and that's typically what people play with. And that's fine, but it's not very powerful. Now, when you start looking at your type of coil designs you can have, I want to show you the good page. Now this is an improvement over that same dimension. So you have, back out a little bit. So you have there to here. Now what you have is much tighter flux when you go through a smaller dimension. See all that wasted flux? Good flux. Wasted flux. good flux. And so here now you can start wrapping your coil wires around like that. You want to do it in stages. I'll show you one more design improvement. And so here was, these were to be just cut out of silicon steel and machine stamped. And so I had little protrusions that I was going to put on there. Now these are to separate so you can wind your coils, kind of like a Tesla pancake type, or the way Doug Conzen makes a directional winding on his coils. So Tesla pancake like that, and you're starting, you're going over here, one over the other, and then another Tesla pancake section and another one. But these are just to help in the winding, and the more you can put in there, the better. Over here, I was trying to experiment in lensing that force and seeing if this is the point where your flux is maximum. And so I wanted to see if you could have zero point action in there by lensing the forces at that point. And actually, in a pentagonal stacking of these